Hello everyone. In today's lecture video, we'll discuss feedback amplifiers. As we all know that amplifiers are the electronic circuits which are used to increase the strength of weak signal. And the next term feedback. Feedback is nothing but a fraction of output signal is taken and given to the input side of a electronic circuit. For example, if I'm considering electronic circuit, any electronic circuit, there will be input and there will be output here. A fraction of output signal and taken and given back to the input signal. This is nothing but a feedback here. So at the input side there are two types of signals. One is input signal and the fraction of output signal will be there. So based on these two signals, this feedback is classified into two types. One is positive feedback and the one is negative feedback. We'll discuss one by one, where the positive feedback is nothing but a fraction of output signal and the input signals are in phase with each other. For example, if I'm considering the feedback amplifier here, this is a basic amplifier. So in basic amplifier will be either operational amplifier or any transistor. And the gain of this basic amplifier, this is basic amplifier. Gain of this basic amplifier is A, and this is a feedback network. So feedback network. This feedback network may be constructed using the passive elements like resistor, capacitor and inductor. So gain of this feedback amplifier, so feedback network is beta. It is also called as feedback factor. So if you consider the feedback amplifier, there will be a basic amplifier and a feedback network. So in this case, using the feedback network, the fraction of output is given to the input side here. In case of positive feedback, both input signal and the fraction of output signal both will be in phase with each other here. That means the phase difference of these two signals will be 0 degrees or 360 degrees. So these types of feedbacks are called as positive feedback. And the total gain of this feedback amplifier, if I'm taking feedback amplifier gain, is A divided by 1 minus A into beta. Nothing but where A is gain of basic amplifier and beta is gain of feedback network or feedback factor. So this is the total gain of positive feedback networks, that is A by 1 minus A into beta. Next is negative feedback, where negative feedback is nothing but a fraction of output signal and the input signals are out of phase with each other. In case of positive, it is in phase with each other. In case of negative feedback, it is out of phase with each other. So if you consider the same feedback amplifier here, the input signal and the fraction of output signal both will be out of phase with each other. Here it is 180 degree phase shift. So it has 180 degree phase shift. So total gain of negative feedback amplifier is A divided by 1 plus A beta. So this is the total gain of this circuit negative feedback amplifier, that is A by 1 plus A beta. For positive feedback, it is A by 1 minus A beta. So these positive feedbacks are used in oscillators, and the negative feedbacks are used in amplifiers. Application for positive feedback is oscillator and the application for negative feedback is amplifier here. In the previous topic, we were discussing about types of feedbacks. There were two types, positive feedback and negative feedback. Here we will discuss about types of feedback amplifiers. There are four types: voltage series, voltage shunt, current series, current shunt. We can observe here the first term indicates the nature of output, so whether either it is voltage or current, and the second term indicates the nature of mixing. As we know that in feedback amplifiers, so at the input side there are two signals, one is input signal and the fraction of output signal. So the second term indicates the nature of mixing, whether they are connected in series or parallel. So first term indicates nature of output and the second term indicates nature of mixing. So in the first case, voltage series means the output of that feedback amplifier is voltage, and at the input side, the nature of mixing, that means input signal and the fraction of output signal is connected in series. And also we should remember here that if it is the nature of mixing is series, means the input will be voltage. If it is series, the nature of mixing is series, means the input is voltage, and if it is parallel or shunt, means the input will be current. So the first term indicates nature of output of a feedback amplifier. Second term indicates nature of mixing, how the input signal and the fraction of output signals are connected. And if it is a series, nature of mixing is series, means the input will be voltage. If it is shunt means or parallel means, then input will be current here. So the second one is voltage shunt. The nature of output of the feedback amplifier is voltage, and the nature of mixing is parallel. So the input will be current. Next is current series. Output is current. Output of feedback amplifier is current, and the nature of mixing is series. Here current shunt means the output is current, and the nature of mixing is parallel. So the input will also be current here. So we'll discuss voltage series feedback amplifier. This is the circuit diagram for voltage series feedback amplifier. It consists the basic amplifier. The gain of the basic amplifier is A, and the input voltage for basic amplifier is Vi, and the output of this basic amplifier is V output, V naught here. And it has feedback network. The gain of the feedback network is beta, or else it can also be called as feedback factor. Input for this feedback network is V output, and the output of the feedback network is Vf. So this is nothing but the fraction of output voltage. So that is given connected in series with the input voltage. Since it is a voltage series, the output of this feedback amplifier is voltage here, that is taken across RL. And the nature of mixing, the fraction of output voltage and the input voltage are connected in series here. So this is the circuit diagram for voltage series feedback amplifier. Now we will see how to calculate the total gain of this voltage series feedback amplifier. First we will take the gain of basic amplifier. So we know how to take the gain, that is output by input. Since it is a voltage series, we will take in terms of voltage. Gain of a basic amplifier A is equal to, input for this basic amplifier is V in, output is V output. So that is V output by V input, Vi. And the gain of feedback network beta is input for input for the feedback network is V output, output is Vf, that is Vf by V output, output by input. Similarly, gain of this total feedback network feedback amplifier is AF, that is input for this feedback amplifier is V in, and the output is V output. So it is V output by V in. So how to calculate the total gain of a feedback amplifier in terms of basic amplifier gain and the feedback network or feedback factor. If you apply KVL here to this loop, so if I'm traveling from here, so it will be, I'm traveling from negative to positive, so the polarity will be positive plus V in. Next parameter is Vi, that is I'm traveling from positive to negative, so it will be minus Vi. Next is Vf minus Vf is equal to 0. Apply KVL. So after applying KVL, so we will get this equation, so that V in is equal to Vi plus Vf. So now if I'm dividing this equation by V output, both the side, left hand side as well as right hand side, so it will be V in by V output is equal to V in I by V output plus Vf by V output. As we all know that here we have written some equations. V output by V in is nothing but the basic amplifier gain. So V output by V in is basic amplifier gain. So it is a reciprocal 1 by A plus Vf by V output is nothing but a beta feedback factor. V in by V output. V in by V output is 1 by AF. So 1 by AF, if you simplify the right hand side, it will be taking LCM 1 plus A beta divided by A. So if you take the reciprocal of this, the gain of feedback amplifier is equal to A by 1 plus A beta. So this is the gain of feedback amplifier, nothing but it is a positive feedback. Sorry, it is negative feedback because we're having the feedback equation as A by 1 plus A into beta. Here the parameters we used are where A is basic amplifier gain and the beta is feedback factor and AF is feedback amplifier gain, total feedback amplifier gain, and V in is input for this feedback amplifier, input for feedback amplifier, and VI is input voltage for basic amplifier, and V output is output of feedback amplifier and basic amplifier, and VF is nothing but the output of feedback network, output of feedback network. So we should remember all these parameters. Thank you.